This section is on some special angles and special right triangles. So when talking about special right triangles in reference to their angles, we talk about 45, 45, 90 triangles and 30, 60, 90 triangles. So in a 45, 45, 90, if one of the sides measures 1, then the other side is also 1, and the hypotenuse is 2. Now, why is that? Well, if this angle is 45 degrees, then 90 minus 45, this one has to be 45 too, which means that the sides are congruent. There you go. For 30, 60, 90 triangle, if one of the sides measures 1, then you can find both the leg and the hypotenuse. The leg will be square root of 3, and the hypotenuse is 2. And that's always the case for 45, 45, 90, and 30, 60, 90 triangles. So in example 1, it says, use this figure to find the cosecant of 45, the secant of 45, and the cotangent of 45. So cosecant is the hypotenuse over the opposite. So if we're looking at this angle, then we've got square root of 2 over 1 or square root of 2. Secant is the hypotenuse over the adjacent. That's square root of 2 over 1 or square root of 2. And cotangent is the adjacent over the opposite. The adjacent is 1, the opposite is 1. So cotangent of 45 degrees is 1. For example 2, similar deal with a 30, 60, 90 triangle. We want to find the tangent of 60 degrees. I realize you already know how to do this with the unit circle, and we've talked about it different ways, but we're just giving you different options here on how you can find these things. So tangent is opposite over adjacent. So if our 60-degree angle is here, then opposite would be the square root of 3, and adjacent would be 1. So tangent of 60 degrees is the square root of 3. And then the tangent of 30 degrees, opposite over adjacent again, but this time we're looking at this angle up here. So the opposite of the 30-degree angle is 1, and the adjacent is square root of 3. So that means the tangent of 30 degrees is the square root of 3 over 3. Find the exact value in each of these situations. So the tangent of pi over 3. Well, the tangent of pi over 3 is the same as the tangent of 60, which we just found. That's square root of 3. Secant of pi over 4 is the same as 45 degrees. So, and we found in example 1 that the secant of 45 was a square root of 2. So the exact value for tangent of pi over 3 minus secant of pi over 4 is square root of 3 minus square root of 2. And that's it. Okay? Don't put it in your calculator. You'll get a decimal that goes on forever. That's not an exact value. And you cannot say 3 minus 2 is 1, square root of 1. No. Put in the calculator, you'll see that won't work. You cannot combine radicals that are being added or subtracted. So that's as far as we can go. And then part B, cosine of 30 degrees. Or, no, excuse me, cosecant of 30 degrees. What is that? Well, we need to find it. If we look back at our 30, 60, 90 triangle, opposite the 30 is 1, opposite the 60 is 3, and the hypotenuse is 2. So cosecant is hypotenuse over the opposite. So that's 2 over 1 or 2. Then sine of 45 degrees, we already found, well, no, we hadn't found that. Okay, let's draw a picture. So here's a 45, 45, 90. Both the legs are 1 and the hypotenuse is square root of 2. So sine is opposite over hypotenuse. Or the square root of 2 over 2. So now we can find the cosecant of 30 minus 2 times the sine of 45. Because the cosecant of 30 is 2, and the sine of 45 is the square root of 2 over 2. Here, the 2's will go away, and we end up with 2 minus square root of 2. And again, that's as far as we can go. And then this is just a list of common trig values. You don't want to have to memorize this. You want to be able to find them. And you can find them by generating the unit circle yourself. But this is a list you can look back to if you like.